Okay, so my chemistry theory class will be starting our last unit tomorrow, which is organic chem. And here would be a summary of our first lesson that we'll be doing together. So organic chemistry, saying that it is a branch of chemistry that deals with all of those carbon compounds. And then we would go over what is an organic compound, and it's essentially anything with carbon in it, but there is some exceptions, and these are the exceptions we want to look out for. So we would look out for carbon monoxide, we would look out for carbon dioxide, we would look out for any ionic compound, so we don't want to see any metals in our compound. We would look out for those carbonates, the Cn negative ion, and carbides, which would be the last one. So if we saw any of those, we know that it's inorganic. So anything else though with carbon would be organic. So then going to, is this going to cut down? Okay. So going to our first old diploma question, this was just being able to identify organic compounds. So the ones that are organic, or the ones that aren't, whichever way you want to go with it. Number 1 would be. Number 2 is not, because there's a metal. Number 3 would be. Number 4 would be. Number 5 is not, because that's carbon monoxide. Number 6 would be. And then number 7 and 8 wouldn't be, for not only is there metal, but they also had those ions that we don't want to see. So for this one, our answer would have been 1, 3, 4, and 6. Then looking at, once we've defined what organic compounds are, there are different branches that we would go through. So what we're going to start with is this one over here, which is alkanes. So we can go through here how we have any hydrocarbon, so containing carbon and hydrogen, and then there's the derivatives, which we'll get into in as we move on in the unit. Then we can break this down even further. So we have alphatics and you have aromatics. When we look at aromatics, it would have a benzene ring present, and then we can talk more about that. But with alphatics, it's just a carbon chain, and there are 3 different chains we're going to look at. So alkanes, which we'll see today, which has only single bonds. Then we'll look at alkenes and alkynes, which has double and triple bonds. Now with organic chem, there's lots and lots of memorization, and we often want to know a stem name or the root name, and those are the names that we're looking at here. So if you only have 1 carbon, it's meth. If you have 2, it's eth. 3 is prop, and it goes all the way to 10. Then you have your side groups, so what can be on the chain. So if you have a CH3 connected to your main chain, you have a methyl group. So we want to notice here that the beginning is still the same, so like 1 carbon is meth, but you're adding YL to the end. Then you also have multipliers. So if you have more than 1, so like if you have 2 of something, we'd say di, tri, tetra, and so on. So all of that will matter, and we definitely will have to have that memorized. But what we're going to again look at first is alkanes. So alkanes do have a general formula, and I usually tell my students, if you love formulas, use it, but you have enough to memorize and you can always figure it out if you know how to draw it. We do know that they are all single bonds. If you only have single bonds present, your atom is said to be saturated, because every carbon would be saturated with as many other atoms as possible, usually with a lot of hydrogens. Anytime we're looking at that, we can identify that we have an alkane because the suffix, the ending of the word, will end in ane. So here are some simple alkanes. So like methane with just 1 carbon, ethane with 2 carbons, propane, and so on, all the way to decane. So if we wanted to name the following based on our structures, and there's many different ways you can draw. So we can have a condensed structural diagram, we can have a line diagram, we can have an expanded diagram. We need to know how to look at all of those. So when you are naming, you want to identify your longest chain. So in this case, we have 1 carbon, 2 carbon, 3, 4, 5, 6. They're all single bonds. So this would just be hex for 6, and then ane, showing all single bonds. If you have a line diagram, we need to remember that every endpoint is a carbon, and then every carbon is bonded to as many other atoms as possible, and carbon in general can fit 4 atoms around it. So this end carbon already is bonded to carbon, so this would have 3 implied hydrogens. This middle one here would have 2, And we can keep going to fill this all up. But really with this one, we just need to know the longest chain possible, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is decane. So dec for 10, A and E for all single bonds. Now, it does get a little bit harder if we do have a side group or an alkyl side group attached to the main chain. So your first step is always to identify your longest chain possible, and it does not need to be in a straight line. So here I'm going to identify my longest chain, and then you need to number your carbons, but you always want to start at the end. That will give you the side group first. So I'm going to number my carbons here, 1, 2, 3, 4, 5, 6, because that gives my first side group on carbon 2. If I started over here and said this was 1 and this one's 2, 3, 4, that would put my first side group on carbon 4. So I know which way I need to go. So on here I have 2 side groups, 2 methyl groups, 1 on carbon 2, right? It's attached to carbon 2, and 1 on carbon 3. It's attached to carbon 3. So when I'm writing this out, I need to say where they are placed. So this would be 2, 3, di, because there's 2 of them, methyl, and then my longest chain is 6, so hexane. So I'm putting everything in here, 2, 3, same where they are, di, because there's 2 of them, methyl, because that's what these side groups are, just 1 carbon side group, and then hex for the longest chain, and then ane for all single bonds. So this next one, same idea, longest chain possible. So I would go straight across, and I'm going to start numbering from left to right. So 1, 2, 3, 4, 5, 6, instead of from right to left, because I want to, again, get that first side group on the lowest number possible. And this one has 4 methyl groups attached to the main chain. So we have to say where each group is. So for this first one, we'd have 2, because it's on carbon 2. This second one here is also on carbon 2. Then we have over here on carbon 4. This one up here is also on carbon 4. There are 4 side groups altogether, so we need the prefix tetra, and then naming your chain, which is hex for your longest chain being 6, and then ane, because there are all single bonds. So I hope this was helpful for a quick glimpse at alkanes and being able to identify organic compounds. If so, please subscribe. And if there's any other video I can do, let me know. I'll do another video very shortly with the homework I would assign from this section that we do right out of our textbook. As always, thank you for watching.